Okay, so vertical stretch is when the absolute value is bigger than 1. Shrink, absolute value is between 0 and 1. Reflection, when A is negative. Horizontal shift, that's for H. Vertical shift, that's for K. And it is intuitive in a sense that you go right. When H is positive. You go left when H is negative. You go up when K is positive. And you go down when K is negative. And we're going to do this like over and over again this week. So it should sink in really nicely. So if you were to come up with your own equation, like let me give you a good example. Y equals -2, x plus 1 squared plus 4. So that's a good example. Tell me what A is, what's H, what's K, and then we'll draw it. So what's H and K here? A is what? What's H? Careful. -1, actually. Thank you, Reggie. It's a trick question. Because it's x minus H. So you have to do minus -1, right? To make it a positive one. So that is a bit counterintuitive. Yes, when H is negative, you go left. When H is positive, you go right. But in the equation, it's counterintuitive. And what's K here? 4. Perfect. Good. So what this means is that compared to y equals x squared, we're going to go 1 left, 4 up, reflect over the x-axis, and vertically stretch by a factor of 2. Compared to y equals x squared. So now let's do it. Let's graph it. Actually, is there room for graphing? Well, no, but I want to graph it anyway. So y equals x squared looks like this, right? Well, plug in 1, I get 1. Plug in 1, I get 1. Plug in 0, I get 0. Where's my vertex now? If I've gone 1 left and 4 up, where's my vertex now? Comma, 4. Good. So it's got to be right here. My new vertex changed. Hence transformed, right? Plus, plug in -1. See what happens. You will get 4. Always a check. Just plug in. Think about numerically, right? Now, is it opening up or down? Because A is negative. Down. That's intuitive, right? What I would do just to be on the safe side is make a quick table. Plug in values close to -1. Give me some numbers close to -1 for x. Like very close by. On each side. What's like right next to -1 for x? On the right side. On the left side is -2 and 0. Perfect. And they should be the same y values. And just plug it in. 0 plus 1 PEMDAS, right? That's why I keep PEMDAS in you guys. 0 plus 1 squared is 1. -2 times 1 is -2. -2 plus 4 is 2. It should be going down, right? You get that for each. See how the graph got changed, right? Compared to the original graph. There's a change. And that's what we need to think of it in terms of that. Yes, you do a small table, but you're not going to do a random table. You got to be intentional about it and make sure you find the vertex and plug in values close to the vertex. And we're going to do this over and over and over again for all kinds of equations. So once you have a general equation, answer the following questions, which we kind of did, right? Identify which parameter affects orientation. Ooh, that's 2y equals x squared in those boxes. My apologies. Didn't see that. Yeah, be able to figure out all those things, right? Remember, this is a k. That's h. That's a and a. As well as orientation, which is up or down. Pointing up or down. Yeah, if A is positive or negative, that's orientation, up or down. So if I stretch graph vertically, we already talked about it. Compress when it's like this. And why have those impacts? Because you're multiplying. You're multiplying y by a. What values cause the graph to flip when a is negative? To shift to the left, that's going to be when h is negative or h is positive. Up when k is positive or k is negative. And our points are going to have to connect to specific parameters. Well, yeah, the vertex is always going to be h comma k. Just so you know, that'll always be the case. Okay, questions? We're good? All right, let's keep moving. Oh wait. Okay, moving right along. Give me notes. Give me one sec. I'll go pick it up. I'll be right back. Let me just position that. I'll be right back. Okay, hopefully everyone's got notes now. All right. All right, let's keep moving, guys. All right. So here's what we're gonna do. We're going to predict the vertex, the orientation, whether it opens up or down, whether there's a vertical stretch or compression. Do not use graph calculator. Make the graph. So you guys go to your table groups. I'll walk around and help you guys out. But I'm gonna at least put down the important information next to each equation. You guys are gonna take that, put it all together, and do the graphs. You can divide and conquer among your table groups. There's 6 equations. There's about 3 or 4 per group. I'm sorry, you guys have 2, but you know, you do more. Anyway, just to give you guys a little push here. The vertex here is -9, 0. Let's do a little table, actually. That might be smart. Here's your equation. The vertex.
Grab the 2.2 notes.
You're hilarious. I'll take it. Sorry, I know I'm giving you a hard time. You're wearing giant shirts. That's all good. All right. Here we go. Anyone else need notes? We're good? Okay. All right, let's keep going. This is gonna open up, up, and down. So basically that's orientation. Actually, hold on, just short space here. Is that gonna be a stretch or a compression? That's neither. That's gonna be a stretch. That's neither. And go through the motions again for the next three. That's gonna be 0,7.
So Mr. Omanchi, if it's
Yeah, go ahead.
the C's, then it's like the inverse.
Yeah, it's the opposite, right? Exactly. It's counterintuitive for the horizontal shift. 100% correct. Good. So part A really quickly. Let's do this, right? Don't need to draw 9 tick marks. That's kind of ridiculous. Make a quick table. Plugging values close. The stretch will be taken care of when you plug it in. You should get 1 and 1. Right? Okay, actually, one of those for you guys. Okay. Do the rest. We'll freeze it. So do the rest. And then we'll check in about, say, 4 or 5 minutes. I'll do them really quickly on my screen, then I'll share with you guys. Oh boy, that was crazy. All right. Put my mask on, something breathe on you guys. All right. Okay. What's on the graph so far? You guys are. Oh. Here you go. Right on the graphs. More. You need some coffee. Yeah. I'm sorry, I'll get through it. I'm out of it. Okay, well, we'll go through it, okay? All right. You doing all right? Okay. I'll reveal the answers in about 30 seconds. By the way, if Mason didn't fumble and scored, my score would have been pretty close. I think it was like 20. We'll score at that time. 21-20, I think, at the time. I think. Could be wrong. No, 23. It was 23. It was 23. Yes, right. 23-21. Right. We went up 30-20 if we scored a touchdown and just stop them next drive. Not meant to be. It's not the end of the world, but I think the team could be 5-0 though. All right. Here we go, guys. So what's happening here? Obviously, we're being boxes. Look for B. That in blue. You guys are up 7 units and just have it point up. And if you're putting 1 and then 1 to get 8. For C, it's down here. If you plug in 0, it's perfect 0, 0.1, and then you want to get 3 in each case, opens up. For D, put it right here. Plug 1 for X, you get 0 for Y. If you plug in like 4 and -2, that makes a multiple of 3. You get 9, you square it. 1/3 of 9 is 3, you get 3 in each of those cases, they have a symmetry after spec. For E, I did right here in the box for A, there were 7, 9, 6 up, went down. I plug in 6, 6, and 8. From 1 away from 7, you get 5 in each case for outputs. And lastly for F, which I do over here in light blue. Vertex -3, -8 opens up. It's stretched by a factor 2, so it looks skinnier for sure. Like those are for the most part pretty close. Plug in like guys close to -2, like -2, -4. You get -6 in each case. So that's what we get. All right, we're good. All right. Now the next part of our lesson. How can I rewrite in vertex graphing form? Okay, this is a big deal. This is a concept. Maybe you guys see, maybe you don't have it. I don't know. Tell me if you've seen it before. I have to check with Algebra 1 teachers here if they've done it or in middle school. It's called completing the square. Okay, so you've seen it. Okay, you know. All right. You hate it. Oh, geez, that's strong. It's a strong word. All right. All right. Well, let me just tell you what to do. It is a bit procedural. What you do is you take half. Actually, let me do a text box instead. Collect the squared and linear term on one side. That means move constant to the other side. The constant means no x. If applicable, does not equal 1. Take half of b, square it, and add that result both sides. Factor your new quadratic, solve by square rooting both sides. Okay. There are your procedures. So let's go through the motions and get it done. So I'll come back to these boxes in a little bit because they're a little confusing right now. Let me actually show you a problem where we use this process. So let's look at number 3. Number 3 is a great one. And I'll come back and do 1 and 2. Oh, whoa. What did I do there? That's crazy. All right. Yikes. Okay. I don't want to keep changing the colors. All right. So yeah, so here's what you do. It's like saying y equals. Okay, which term does not have x? Move it over. How do you move it over? Perfect. Okay, a is the number in front of x squared. You don't see a number, so you assume it's 1. So you're good. If it's not 1, we'll deal with that. I don't think we'll deal with that today. That's a little too much. It's probably why Reggie don't like it. We'll say don't like instead of, or dislike instead of hate. Hate's a little too strong. Right? I get you. All right. So I've done this. I don't need to do this because it's not applicable, right? So I have x squared 8x on one side, y minus 10 on the other side. Now take half of b and square it. My b value is 8, right? What's half of it squared? 16. I mean, you're right on the right track when you say 4. So you had 16 on both sides. So now it becomes this, y plus 6. Okay, in this case, I'm not solving. So don't worry about that. We're just rewriting the equation. We're not solving anything. How do you factor this? X plus what squared, guys? Close. 4. Because 4 squared is 16. And where does the 8x go? It comes back. How does it come back? If I multiply x plus 4 by itself, do I get 8x in the middle? You do, right? Because you get 4x and 4x. You do get 8x back. So it's taken care of. And then lastly, you bring the 6 over back to the other side. Guess what you just created? Vertex form. There's yet another way to do vertex form. I'll show you guys that probably tomorrow. Not tomorrow, sorry, Wednesday. There's a formula you can use that kind of ties the quadratic formula, but that's the way you do it. So we're going to practice this a few times for number 4. I'll kind of get you guys queued up or set up, and then you guys can go through the motions. That's what you do. If you're to graph this and graph this, you get the same exact graph. They're 100% the same thing. It's just a cosmetic change. But why is that important? It's important because you want to identify the vertex more easily when you have a vertex form, understand the transformations as well. It's a process you will need to be well versed in as you move on to calculus. You just have to kind of use this technique as you get to more advanced stuff. It needs to be part of your toolkit. For those who are doing PSAT next week, they do ask these kind of questions. If you get to the second module, which is a little tougher. Anyone did SAT last Saturday? So I heard the second module is really tough. But anyway, if you do well in the first module because it's adapted by section, the second module becomes tougher. These are some of the second module questions, like dealing with vertex form. Okay. Let's come back and look at these really quickly. So all you have to do is kind of recognize the fact that, well, there's an X here. Does that make sense? You guys remember this from CPM, right? If you took Algebra 1 here at the middle school or geometry, maybe you guys did this. That's X and X. What are you going to put here and here? You see why it's 4 and 4? Because what's X times 4? 4X, right? So what are you going to put in that lower right corner then? 16, perfect. So what ends up coming X plus 4 squared? Well, here I do the same thing, right? 3 and 3. See, they're identical on the outsides. So it becomes x squared plus 6x plus 9, or x plus 3 squared. Just like how this was x squared plus 8x plus 16. So you can use that to help you. But procedurally, you take half of b, square it, add to both sides. So we'll do the same thing here, right? Most likely, what's half of 8 then squared? Perfect, good. So what does that become on the right side? X plus 4 squared. All makes sense? Cool. Okay. Okay, lastly, number 4. And we wrap up after this. You guys did great today. So take half. So for A, start by doing this. For B. Good. Yes. You guys get the idea. I'll let you guys go through the motions. Ooh, that's a juicy one. When you have odd number for B, it can be a little crazy because you have fractions. All right.
Take half of-
Yeah, 5, which is 5 halves. It's insane. Kind of a little bit intense. Another reason to dislike the process when you have fractions. I would agree that it's not nice. Okay, I'll write these in and then we'll wrap up. See here. All right. So at the very least, you guys should have this. 9, 9, 4, 4, 25 fourths, 25 fourths, 49 fourths, 49 fourths. Or half of 5. You can, it's gonna make the factoring tougher. So I wouldn't recommend that because easier factor a square root of fraction. I wouldn't fault you for it, but you're making the math harder for yourself if you do. So I'll write the answers in pink right next to them. Because that becomes 2, right? You have to move it over. Y equals x minus 2 squared plus what?
7.
Awesome. Think of that, Alexander. It's great. Oh, geez. It's crazy. So you can write x plus 5 halves because square root of 5, 25 fourths is 5 halves. And we add -2 to 5, 25 fourths. Yeah, you guys gotta be really cool with your fractions, unfortunately. If you do -2 plus, what's -2 as a fraction with 4 as a denominator? No, -2, -4, right? So then you get 17 fourths, but you have to move it over. So it's minus 17 fourths. I don't know, kind of crazy. And then here, y equals x minus 7/2 squared. And then 41/4, so we gotta subtract it. There you go. Okay. Those are net. So the homework packets, which I have right here. You guys get a head start, you can just wait till later. Not do till Wednesday. And we'll do another lesson on Wednesday. Friday, I want to start talking about the test. The next week is short week. We just grade review next week and then take the test. And then we'll talk about what is scheduling. It's supposed to be Wednesday, but the same day as the PSAT.
Wait, next day we have Friday off, so next week.
Yes, we have Friday off, yes.
One week, 2 days.
Yeah, and then also the fucking pops. Yeah, so we're gonna do some more, we're gonna start doing the review together on Friday. Yeah, we talked to this long. Yeah, that's a lot.
What time is that?
7:30.
7:30? Is it Mando?
Virginia. Joe.
But like, when I was supposed to like study for.
You are.
It's like supposed to be benchmark.
Yeah, it doesn't count for anything unless you do really well in your
Sean, are
junior.
you studying?
But really well means like 10 to 12 questions overall.
That's good for a PhD.
Then I'm gonna actually study for a real one. I'm
Yeah.
16,
I'm just taking it for fun, because I'm taking the ACT.
What's the difference?
We're gonna get rid of it in March or April.
You're getting rid of
Science,
it.
yeah, they'll get rid- yeah, and they're gonna incorporate the data table with other categories, whether that can tell that, you know.
The ACT.
So the ACT is all like.
The math is more advanced, I mean, it does start from trig. Which we'll do in this class, we don't cover quite all of it. The SAT though,
Why are you taking that one?
That's nice.
the second module has some really tough questions.
And I did way better.
Like I got some test path back to show you guys, and we're here Friday because sports is dominating our school on Friday. Oh, I haven't updated the grades yet. I'm gonna do that for my third grade today, so I'll make you step up. So everyone's gonna get on hot sheet. Yeah, and then these scores will only go up if you guys do well next test, right? Do well next test, the scores will
How much?
up to 80%. Which would be huge,
Up to 80%.
up to 80%, yes.
Wait, so it's not added up, so it's not less, like, state?
So what'll happen is that I'll go to school fee, like, let's say I got 65%, that will have to go 65%, right?
Yeah.
And say you do really well on the unit 2 sub score on our next test. Say you at least get 80%. Then I'm gonna replace that 600 with 10%.
Okay.
And that's gonna,
Like a section.
yeah, exactly, yeah. And that's gonna be huge, that's, a lot of people are gonna make 80% jumps afterwards.
Hypothetically, you got a 60 on the last.
Trust me.
Yeah,
And you
Like,
get-
so you have to
like,
get a
hypothetically-
100%.
So hypothetically, if you had 60 on the last test. And let's say.
Would you?
I'm gonna. Which will.
So if you get, let's say you get 80 on this. Then you would get 88 instead of just 80.
Actually, don't think I changed the grade.
Yeah. Because right now, I'm still with the big bets.
Just for equal questions
Oh, hold on, I gotta stop recording. Yes, go ahead, yes. Yes.
that we can,
You know, Alzheimer's been kind of slow now. They're gonna come tomorrow, yeah.
thank you so much.